In Figure A3-T72-04, a service switch is closed and depressing the start push button turns an indicator light on. Releasing the start push button turns the light off. So which of the following would explain this? A, B, C, or D? Let's take a look at the circuit so we understand its normal operation and then wonder to ourselves, is what's described in the question normal operation or abnormal operation? And then try to figure out why, if that's the case. So we have a standard arrangement of a holding circuit, and a holding circuit utilizes the following devices. You have a start and stop button, which are typically contained inside the exact same housing. Usually there's a green push button for start and a red push button for stop. And I'm using the word push button specifically because start and stop buttons are spring-loaded buttons. And just as an example, the normal position of a start button is to be normally open. And that's because there's a spring inside the actual switching box that holds that button open. The only way you can close it is to overcome the spring force with your finger by pushing it down. And sometimes we indicate that on a drawing like this. Push down on the top of the button, and then you end up closing the switch. The second button is the stop button, also spring-loaded, but it's spring-loaded in the opposite orientation. A stop button is normally closed, and it's the spring inside the actual switch that holds it in the closed position until once again your finger comes along and presses the stop button. So we have a start and stop button wired in series when we have a holding circuit arrangement. And then the next device you need is a relay. So here's a relay coil, and its normally open contacts are over here. And notice the normally open contacts are always wired parallel to the start button. So it's a standard arrangement, right? You have start and stop button wired in series with the relay coil, and the relay's normally open contacts will always be wired parallel to the start button. And let's talk about the operation and why we would do this. Why we would do this is so that if you have a load, like a light like this, then the moment you press the start button, even if you take your finger away from the start button, the load stays energized. So you have this sort of, instantaneous or momentary starting of a switch. And this is usually used on bigger loads like large pumps and large fans, and the switch is usually placed at a physical distance away from the moving part of the motor that the switch is turning on, and that keeps you physically displaced from the danger area. So the idea is you have to move away from the machine that the start button is actually turning on, and you can start it and it'll keep running, but the moment you press stop, everything turns off. Okay, so let's take a look at its function and how the holding circuit works. So as it is drawn right now, you can see my start button is shown open and my stop button is shown closed. My relay is clearly de-energized and its normally open contacts are in their normal position, which is open. So the light would be off. So just to indicate the light being off, I'm going to put an X through it. Now, if you close the service switch here, close that switch, and then push the start button with your finger here, what will happen is while you're pushing it down, you'll establish continuity by closing the start switch. And when that happens, current can now flow like this. And as soon as current flows like that, you'll energize your relay coil, and then over here, its contacts will close, which means current can flow through the parallel branch around the start button. Now, why is that important? It's important that current flows through the parallel branch around the start button so that you can release your finger and expect the circuit to stay operational. So now I'm going to remove all of my annotations and show you exactly what it's going to look like when you press the start button and release. So you close the switch, press the start button, current will flow through the start button, energizing the relay. Now, take your finger, and I should point out that the relay contacts will close, and we have to also mention that the light will be on, right? Because it's wired parallel to the relay coil. So my light is running, and all that is great. But now let's take our finger off the start button. So I'm going to show an arrow up this way. I'm removing my finger. The spring is going to return the start button to its open position. And one would think that we would lose continuity across the start button and the whole circuit would turn off, but that's not the case. And that's because we've set up that parallel branch for current to flow like this. Remember, we energized this relay when we pressed the start button and its contacts closed here. So we already have current flowing around the start button like this, keeping the relay energized and the light. So even though we remove our finger from the start button and it goes back to the open position, we have a relay holding the light in operation. So our question says that when we press the start button, the light turns on. But when we take our finger off the start button, the light turns off. And that immediately means that there's no possible way your holding circuit's working, and it must mean that the relay is not operational. The answer is B.